Dude, we are live for the second time today. I don't know if I'm gonna be posting the VOD for the earlier stream. Um, I don't see why not. I don't know. I'll see. I don't know. I don't know if I'm gonna post. Either way, we are live for the second time today, and earlier I had mentioned that we're gonna be doing some data science stuff, but I changed my mind. We are going to be learning, and I mean, in my case, kind of relearning, but I mean, not really relearning, because like, okay, we're going to be learning about the Transformers library, the Hugging Face Transformers library, and the reason I said that it's not really learning, but rather relearning, but really it is still learning for me because no, is because I did learn I did learn about the Transformers library a couple months back, or maybe it was a year or two back. I don't remember. But I did start learning about Hugging Face Transformers, but then I kind of got distracted with other stuff and I just pushed it aside. I did plan on eventually getting back to it, but it just didn't happen because a bunch of other stuff came up. Which, I mean, it kind of worked out for the best because all of that other stuff was also necessary. The Transformers library is great for working with pre-trained models, or rather working with already made models, which is a great thing. There's probably a bunch of other things that the Transformers library allows you to do and helps you to do, which we're going to learn, along the way. But one of the big things about the Transformers library is that it gives you access to a bunch of different models, or rather, I should say, it gives you easier access to be able to just use those models without having to implement them yourself and without having to do a bunch of the other things that you're required to do with certain models. Because, like, with certain models, there are a couple of steps that you have to take in terms of using the model. Whereas with the Transformers library, they aim to make it so that there's as few steps involved, or rather, it's not as complicated as trying to use the model by itself. Okay, so yeah, today we are going to be learning about the Transformers library. One other thing that really encouraged me to do stuff with the Transformers library is that apparently Kaggle notebooks already have. So okay, Kaggle notebooks, they or rather the environment that the Kaggle notebook is running in, it already has a bunch of packages installed. It's a pretty long list of packages, a whole bunch of data science related stuff, and a whole bunch of, well, there's packages for a bunch of different things, but there's definitely a lot of data science related packages. Anything data science related that you can think about, at the very least, the basics, you're gonna have them already present there. Stuff like NumPy, Pandas, Matplotlib, scikit-learn, SciPy, and so on. I think Seaborn is also part of it. PyTorch, TensorFlow, all of this stuff is part of the environment. It didn't occur to me. I think it didn't occur to me because I didn't start using Kaggle notebooks more regularly until like maybe a week ago. But yeah, today, actually a very short while ago, it occurred to me that, hey, let me. Oh, okay. One of the things that brought me back to Hugging Face, I mean, I was on and off of Hugging Face, checking out like a bunch of different models and stuff. There's a model that Microsoft released recently. It's called Omni Parser, And I was looking into that, and I found in on the models page, I found. Hold on. Let me show you. It's better if I just show it to you. So let's open up Hugging Face. Unfortunately, we're gonna have to deal with this light mode thing because they've locked dark mode behind an account. And in this private browser, I'm not logged in to Hugging Face, so we're gonna have to deal with the light mode thing. But it's not that bad. Oh, okay. So, uh, I like that already they already have a bunch of stuff over here, like in terms of suggestions. Okay. What was I gonna look for? Omni. Yeah, there it is. So on this page, if you look at this and then you click transformers, it gives you the code that you would need. Okay, to be honest, I haven't fully understood how I'm supposed to use the model yet. I feel like if I go back and learn the basics, which is what we're going to be doing, if I learn the basics of the transformers library, I might have a better idea of how I'm supposed to be using this. Um, but yeah, that's this whole thing is what and actually I kind of like that there's this option. So if I come across any other models on Hugging Face, and I want to, if I'm wondering, hey, is this supported in transformers, I can just click on this and click on transformers, and then it gives me the code. That's convenient. Okay, so um man, the intro didn't go the way that I thought it would, because I just sort of I just branched out big time. Okay, all right. So we are going to be learning about the Transformers library today. Did I mention that? Um, Sorry. Did I mention that? Okay, yeah. Sorry. Did I mention that that Transformers is part of? It's one of the packages that's installed in the Kaggle notebook environment. That's also another reason why I was super tempted to start doing Transformers stuff as well, because this is great. I'm not gonna have to run the model on my own machine. I won't have to download it onto my own machine either. Speaking of downloading, I think I need to give this notebook internet access. Um, Give me a second. It's just a switch that I have to turn on, but like I need to make sure that there's nothing nothing is gonna show up. Oh, okay, the internet is on by default. Okay, all right, cool. Okay, so yeah, I'm not gonna have to run the model on my machine. I'm not gonna have to download it onto my machine. Everything is gonna be done in this notebook, and we have good resources here. We have, of course, the CPU, and we have about, well, this says about 60 GB. It says 57 GB. And then we have about 30 GB of RAM. Oh, yeah, did I mention the 60 GB is the disk space? And we have about 30 GB of RAM. That says gib. I think that's Gibby bytes. Not gigabytes. I don't know. Either way, uh, so yeah, I'm excited to get into Transformers stuff again after going away from it a while back. So let's get started. Okay, so Transformers provides APIs and tools to easily download and train state-of-the-art pre-trained models. Using pre-trained models can reduce your compute costs, carbon footprint, and save you the time and resources required to train the model from scratch. These models support common tasks in different modalities such as natural language processing, computer vision, audio, and multimodal. Okay, and for each of those, they've given a bunch of different tasks that are supported in like that category. Okay, Transformers support framework. Hold on, what? Transformers support framework interoperability between PyTorch, TensorFlow, and JAX. This provides the flexibility to use a different framework at each stage of the model's life. Train a model in 3 lines of code in one framework and load it for inference in another. Oh, that's interesting. Okay. Models can also be exported to a format like Onyx and TorchScript for deployment in production environments. So what I was wondering is, how is that working? Like it mentions here, train a model in one framework and then load it for inference in another. How is there interoperability between the two? Like, what is transformers converting? I need to look into this. How is it doing that? How is it because when I thought about interoperability, my mind went to Onyx because Onyx allows pretty much that. Like you could create a PyTorch, you could create a model in PyTorch, export it to the Onyx format, and then you can run it anywhere that Onyx is supported, or you can run it anywhere that there's an Onyx runtime, right? I think Keras might support a similar thing as well for Onyx. I haven't looked into it, but there might be. But that was where my mind went. But now I'm curious, since they mentioned Onyx and TorchScript separately, now I'm curious about how Transformers makes it so you can train a model in one framework, but then run inference using another. I guess we'll find out later. Okay. All right. Cool. So we will start with the getting started thing. Okay, the documentation is organized into 5 sections: getting started, tutorials, how-to guides, conceptual guides, and then the API. Okay, I guess we start with getting started. Hold on. Supported models and frameworks. The table below represents the current support in the library for each of those models. Whether they have a Python token. Hold on, dude. I need to reread that sentence. Okay, the table below represents the current support in a library for each of these models, whether they have a Python tokenizer called slow. A fast tokenizer backed by the tokenizer's library, whether they have support in. I'm dude. I'm not able to understand the way that these sentences are structured. Yo, Summer, welcome to the stream. Hello, hello. How are you doing? And why am I a meanie? What happened? Oh God, hold on. Wait a minute. Oh, okay. Yeah. Just because? Okay. Sure. Yeah. All right, cool. Um, so like I was saying, uh, I did not understand either of these sentences. So the table below represents the current support in the library for each of those models, whether they have a Python tokenizer called slow, a fast tokenizer backed by the Python, no, by the tokenizer's library, whether they have support in JAX, PyTorch, and or TensorFlow. Is this supposed to be a is this supposed to be a comma? I'm still having trouble understanding both of these sentences. Like the way that these sentences of yeah, I'm not getting it. You probably need to hydrate. Yeah, yeah, I think so. I think so. Let me hydrate. Give me a second. Thank you for the hydration reminder. Dude, winter is coming. So that's exciting. Our winters are usually pretty short, but let's enjoy it while we can. It is starting to get colder slowly, but yeah, yeah. So we're gonna take a look at this table so I can understand. Okay, the table below represents current support in the library for each of those models. Okay, so it represents support for each of these models. Each of these models has support for either PyTorch, TensorFlow, or Flax. Oh, could this mean interoperability between them? Because, dude, I'm going to be honest, I did not understand these two sentences. It's the way that the sentences are written that I haven't, like, it just went over my head. Uh, it, it could be me. Maybe I'm just not getting it. I haven't connected the dots yet about what exactly these two sentences are saying, but I just did not understand what they're trying to say. Either way, okay, we can. So this is the entire list. Is the rest of this page just the list of? Oh, okay. So where's the getting started section? Because it mentioned getting started, but there's no getting started section here. There's a quick tour. There's installation, adding a new model to transformers. There's the guides. There's also no link to. Oh no, this is quantization methods. Okay. I guess let's take a quick tour. Get up and running with. Wait, dude. Okay, where's the getting started section? Let me just zoom out real quick so a bunch of the other stuff pops up. Oh, we are in the getting started section. Oh, okay. Now I get it. So get started is here, tutorials is here, and then below we have a bunch of how-to guides and conceptual guides. And then there's the API somewhere down here, I think. Oh, conceptual guides is a separate thing. Okay. And then there's the API. All right. Now I get it. All right, so let's jump into the quick tour. We can zoom back in and start. All right, get up and running with transformers. Whether you're a developer or an everyday user, this quick tour will help you get started and show you how to use the pipeline for inference, load a pre-trained model and preprocessor with an auto class, and quickly train a model with PyTorch or TensorFlow. If you're a beginner, we recommend checking out our tutorials or course next. Course. Okay, let's take a look. Uh, let's open that up. Okay, so this course will teach you about NLP using libraries from the Hugging Face ecosystem, transformers, datasets, tokenizers, accelerate, as well as Hugging Face Hub. I wonder if that I wonder if that popped up. Fortunately, it didn't. Okay. Wow. Wow. That is just wow. Okay. Okay, so uh it says here if you're a beginner, we recommend checking this out next for more in-depth explanations of the concepts introduced here. I think that's the best thing to do because okay, here we have installation. Yes, exactly. Wow. Avast is just holy shit. Like my god, dude. Okay, before you begin, make sure you have all the necessary libraries installed. Pip install, so and so, evaluate, accelerate. All right, let's check if we have. Oh, Sama, check this out. Check this. Actually, I think you can see it. You can see the cats and dogs and stuff. Uh, this is a mode that's there in this notebook. Yeah, it's kind of cute. Okay, so pip list. So let's see if what all are we looking for? We're looking for data sets. So I feel like okay, the course is taking us through NLP, but but rather than just NLP, it's going to be introducing us to the Hugging Face ecosystem itself. Um, so stuff like transformers, data sets, tokenizers, whatever Accelerate does. I feel like all of these are going to be used in a bunch of different tasks, not just specifically in NLP. So like they're using NLP as one of the things that we'll be learning because they could have picked anything and they picked NLP. So yeah, I feel like it's going to be beneficial either way. And like regardless, I was interested in NLP anyways, so it kind of works out for the best. Who knows? Through this, I might get to learn the basics of NLP. right? I was planning on doing research on NLP anyways, and if I'm able to be introduced to um, NLP related topics through Transformers or through Hugging Face, then I mean, I'm not complaining. I'm okay with it. How? Wait, what are we looking at here? Okay, so this takes us through an installation thing, and then there's the pipeline. Okay, all right, okay. Uh, so this is going to be running us through a couple of different things here, but then later on we're going to go into more detail with them. All right, okay, let's do it. Oh, first things first, I need to make sure that the thing is installed. Okay, so we need data sets. Let's see if data sets is installed. Yep, data sets is installed. Let's go down to T. I know transformers is I know transformers is installed. Because I checked that earlier. T R T R. Yeah, there it is. Transformers. What else? Evaluate and accelerate. Okay, so let's go back here. EF. Okay, evaluate. We have eval. We don't have evaluate. Okay. Then we need accelerate. Accelerate is installed. Okay. What about evaluate? Like how does that work? Um, is it evaluate? Do I need evaluate? I'm sure they must have thought about this. Maybe I'm missing something here. Yeah, maybe I'm missing something here. But okay, we can start. Before you begin, make sure you have these libraries installed, and then also make sure you have your preferred machine learning framework, which in my case is PyTorch. And then, dude, you know what I realized? And I keep forgetting to change it. It's this. So in my streams, I like to have the logos of various things that I'm using. Um, so back when I was looking into Kaggle stuff, I believe I'd I'd placed the Kaggle logo as well. Right now on the screen, you can see the Python logo and the VS Code logo. And since I'm not using VS Code right now, I think I can change it to Kaggle because I am quite literally using Kaggle. You know what? I can change it. I can change it on stream. I don't remember if I have the I don't remember if I have the Kaggle image. You know what? We'll find that out. We'll find it out live. I don't remember if I download. I think I did. Yeah, I think I did. No, no, that was scikit-learn. I don't remember if I have the Kaggle stuff. Let me just check. Oh, I have one here. Yeah, 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 I have one. So, yeah, I can put this on the screen. I can move the Python logo down here and then bring the Kaggle logo here. And I think we are good. I think the Kaggle is a little too big. Though, to be fair, since I'm doing Transformers stuff, instead of Kaggle, I could have added the Transformers logo, the Hugging Face Transformers logo. Actually, just the Hugging Face logo. I could have added the Hugging Face logo. That makes more sense, doesn't it? Because we are learning about Hugging Face. I feel like that makes more sense. Though I would need to download stuff. So maybe I can do that later. Yeah, yeah. Let's do it later. Okay. Uh what was I doing? Yeah. So pipeline. The pipeline is the easiest and fastest way to use a pre-trained model for inference. You can use the pipeline out of the box for many tasks across different modalities, some of which are shown in the table below. Um, okay, we have text classification, text generation. Oh, okay, there's the modality. NLP, computer vision, audio, and multimodal. Okay. Oh, good. They also have something for image segmentation. There's a couple of models that I've been seeing being released, and which was the latest one that I wanted to test out? I had looked into it. I don't remember. There was also another one which I'm blanking on the name right now, but there was one for generating depth maps and normal maps for any given image. So you could feed an image into it and it would give out a depth map and a normal map. And that's really useful, dude. Oh shit, I missed the ad timer. Okay, there's an ad playing right now, so I'll take a hydration break. All right, welcome back. Okay, so this is great. So we have stuff for text classification, text generation, summarization, image classification, image segmentation, object detection, audio classification, speech recognition, visual question answering. Answer a question about the image, given an image and a question. That's interesting. That is very interesting. In fact, okay, this model, I didn't tell you guys what this. I mentioned this model, Omni Parser. I didn't tell you what the model was for, because I had seen a tweet earlier, and I was seeing this model being used for something. In that tweet and in the demo video, this model was being used for getting a description of the UI. So you could feed it an image of. I believe you're feeding it an image. I don't know exactly. I guess we'll find out later. But you feed it an image of like a website, and it gives you a description of the entire UI. And that's great. That's really powerful because when you have a model that is able to give you a description of a website, not just a description, it gives you all of those elements. It gives you information about the elements. That basically means that the model is able to understand the UI design, and that means that you can then use another model or just some simple code to interact with the website, because you now have a model that knows where the various elements are, and maybe it has some idea of what those elements do as well. But okay, let me read the description or the model summary here to give you a more accurate description of what the model does. So OmniParser is a general screen parsing tool which interprets slash converts UI screenshot to structured format to improve existing LLM based UI agent. Training datasets include an interactable icon detection dataset. Oh, okay, that's interesting. So you could train this model to do other stuff than just detecting UI. Because it mentions here it's a general screen parsing tool, so you could technically train this model on different types of data to do something other than what it's currently being used for. Though I don't know how simple it would be to train this kind of model. This model hub includes a fine-tuned version of YOLO V8, which is, from what I remember, a computer vision model. Actually, there was another model that is based on YOLO. I don't remember what it was called. I think it was called, and not just a model. I think it's a framework. Um, I think it's called Supervision, and it has one version of YOLO as well. I've been meaning to try that out as well. That's like a whole other framework of its own. Or I guess you can say it's a collection of models. I'm not sure how to say that. But you can do a bunch of things with it, like object detection, object segmentation, a lot of computer vision related stuff you can do with it. But yeah, okay, let's carry on reading this. So the training datasets include an interactable icon detection dataset, which was curated from popular web pages and automatically annotated to highlight clickable and actionable regions. And two, an icon description dataset designed to associate each UI element with a corresponding function. Okay, all right. So basically, this model can look at a UI screenshot and get an understanding of what the UI is, or more specifically, what the UI elements are. OmniParser is designed to be able to convert unstructured screenshot image into structured list of elements, including interactable regions, location, and captions of icons on its potential functionality. OmniParser is intended to be used in settings where users are already trained on responsible analytic approaches and critical reasoning is expected. OmniParser is capable of providing extracted information from the screenshot. However, human judgment is needed for the output of OmniParser. OmniParser is intended to be used on various screenshots, which includes both PC and phone, and also various applications. Okay, all right. All right, so let's get back to Transformers. Okay, start by creating an instance of pipeline and specifying a task you want to use it for. In this guide, you'll use the pipeline for sentiment analysis as an example. Where's my notebook? Here. Okay. Uh, actually, we can do it up here, right? Nah, let's do it down here. Okay, what was it? From transfer, I forgot what the code was. From Transformers import pipeline. All right, give IntelliSense a second. Where's the list? Oh, could it be because I haven't run this? Well, I mean that's silly. That would be a silly reason for it to not work, but let's see. Yeah, no, that's not the reason. Why is this not working? Transformers is installed. Okay, whatever. Let's run this. As long as this runs, we should be good. And then we create a classifier object to do sentiment analysis. Okay. All right. Is it done running? Yes, it's done. Okay. So classifier equals pipeline. What is it? Yeah, pipeline. Where's the IntelliSense, dude? Okay. Yeah. I think it's working. It's kind of working. I'm curious about what's going on here because when I'm hitting, oh, okay, now it's working. So it took some time to sort of get it going. Now it should be working. Okay, sentiment analysis. Is that how it's written? Yes. All right. The pipeline downloads and caches a default pre-trained model and tokenizer for sentiment analysis. Now you can use. I remember the last time I had to do this, I had to wait for the thing to download for some time. Let's see how quick or how slow it is here. Oh God, that was quick. That was quick. That was holy shit. That was so quick. This downloaded at 249 MB per second. You're joking. I had to wait for some time for the thing to download. Was it this or was it some other model? I don't remember. I think it was this. I think it was this. But I mean either way. Okay. Downloads and caches a default pre-trained model and tokenizer for sentiment analysis. Now you can use the classifier on your target text. All right, cool. So we can call the classifier as a function and pass in this is a sentence. I'm having a good. Oh, what just happened? Oh, wait. It's the thing. Yeah, there. I'm having a good day. And the result is here, positive. I'm having an okay day. The result is positive. Okay, I'm having a bad day. The result is negative. Okay, cool. Um, if you have more than one input, pass your inputs as a list to the pipeline to return a list of dictionaries. Okay, let's try that. Results equals classifier. We have to pass it in as a list, right? So let's do that. Okay. Um, why are they driving so fast? Okay. Um, the food is too hot. Okay. Um, um, this music is nice. That's going to be positive, obviously. Okay, then also let's just print out results. Okay, so the first one was negative. The second one, I like that. Okay, why are they driving so fast? That that got recognized as a negative, and then the food is too hot is also negative, and then the music is nice is positive. I like that. Okay. Oh, there's also a score associated with each one of them. Let's try to give it like a neutral thing. What is score supposed to be? Is score supposed to be the model's confidence in its answer? And that answer would be, or rather, I think in terms of neural networks, it would be more like the probability of it being something. So it's classifying it as, oh, it's so and so thing, and we are getting the probability. Okay, so the pipeline can also iterate over an entire data set for any task you like. For this example, let's choose automatic speech recognition as our task. And then we're going to use the wave to vec so and so speech recognition. Oh, so that's going to recognize the speech, and then okay, it's okay. That's a speech to, well, it's speech recognition. I don't know if it also outputs the text. Load an audio data set. See datasets quick start for more details. Okay, load an audio dataset you'd like to iterate over. Okay, so they have datasets available for us. That's great. Okay, cool. For example, load the so and so. What dataset is this? Uh, this is a training and evaluation resource for intent detection task with spoken data. It covers 14 intents extracted from a commercial system in the e-banking domain associated with spoken English in 14 diverse language varieties. Okay, all right. All right, so we're going to look into. Okay, good. So other than scikit-learn, we now also have data sets from here, so we can see what kinds of data sets are going to be available. Though with Hugging Face, or with, well, yeah, with Hugging Face, I feel like we're going to have to download the data sets, which isn't a bad thing. I'm just saying that we're probably going to have to download the data sets. To be fair, even with scikit-learn, not all the data sets are just available out of the box. Um, they have a separate section of datasets that actually need to be downloaded, and then there's a separate section of datasets that are available with scikit-learn. Okay, so let's try this new thing. Um, import torch, and then I guess we can get rid of all of this. Speech recognizer, pipeline model. Okay, speech recognizer equals pipeline, uh what was it, speech recognition, automatic speech recognition. And then we have model down here, which would be Facebook. Okay, let's just copy this name. Okay, load an audio data set you'd like to iterate over. For example, load so and so data set. All right, let's do that. From datasets, import load dataset and audio. And then dataset equals load dataset, so and so. Okay. Uh, let's just copy this because I'm not going to remember a bunch of the names. Though, to be fair, no, I just needed to copy this. I could have just typed out all of the other stuff that I could have remembered. Um, you need to make sure that the sampling rate of the dataset matches the sampling rate of so and so, matches the sampling rate that so and so was trained on. Okay. All right. Dataset equals dataset.cast column. All right. Let's open up datasets because I'm not sure what cast column does. So I think we need to wait, what just happened? Quick start audio. What are we looking at? This is in audio. How did we jump to audio? We were hold on. Hold on. What? Oh, this is in datasets. This is quick start in datasets. Okay. All right, datasets is a library for easily accessing and sharing datasets for audio, computer vision, and NLP tasks. Load a dataset in a single line of code and use our powerful data processing methods to quickly get your datasets ready for training in a deep learning model. Backed by Apache Arrow format, process large datasets with zero copy reads without any memory constraints for optimal speed and efficiency. We also feature a deep integration with Hugging Face Hub, allowing you to easily load and share a dataset with the wider machine learning community. All right. Okay. Cool. So the audio files are automatically loaded and resampled when calling the audio column. Extract the raw waveform arrays from the first four samples and pass it as a list to the pipeline. Okay, hold on for a second. Wait, we need to do a couple of things here, right? Yeah, dataset equals dataset.cast column. Is IntelliSense working now? Yeah, there. Well, why did I say is IntelliSense working now? It was working before as well. Oh, it mentions it's a wrapper function. It mentioned that somewhere, that it was a wrapper function. Or maybe I was looking at something else. I don't know. Okay, cast column to feature for decoding. What does that mean? Cast column to feature. Because like when I think about feature, the only thing I can think about is like casting it to a feature that's going to be fed into a neural network. But like conceptually, I know what that means. I don't know if that's exactly what this is. Even if it is, conceptually, I know what that means, but like I don't actually know what's going on here. Um, I guess you know what, we'll find out over time. Audio. So this is interesting. Cast column audio. Right. Real quick. So we're gonna run this. I think it's gonna have to download a couple of things. My God, this is so fast. This is so fast, dude. This is crazy. All of this stuff. Well, I mean, these things are in KB, so that's not a big deal. But like, wait, what is this? This repo contains custom code which must be executed to correctly load the dataset. You can inspect the repository content at so and so. Okay, you can avoid this prompt in the future by passing trust remote code. Let me look into what this is. The code is not running on my system anyways, but like, and I mean, I trust the Hugging Face tutorial, um, but I wanna I wanna find out. Poly AI custom code. Oh, maybe I should add Hugging Face dataset Poly AI custom code. The repository for so and so. Oh, maybe I should look. Hold on. Dataset mines 14. Uh, I'm trying to figure out. Okay, contains custom code which must be executed correctly. No, which words? Holy shit! Custom code which must be executed to correctly load datasets. Fuck me. Why was that so hard to say? Or correctly load the dataset, whatever. Um, Hugging Face dataset custom code warning. Let's say that, or let's type that. Dataset repo requires arbitrary Python code execution. Yeah. Okay. So I think this person is asking the question because I'm just curious about what's going on here. The viewer is disabled because so and so Python code execution. Why? It worked well before. By the way, load datasets works, and the viewer works yesterday. We had to disable the viewer for datasets with a script for now because some people were abusing it. Sorry for the inconvenience. We are seeing if there's a viable long-term solution. Oh, this is not okay. This is not answering the question. You know what? Maybe I can just ask Llama. When I'm actually okay, I need to give it some context. Oh, I have Llama running here, right? All right. Um, what are we saying? Okay, so I'm learning how to use the Hugging Face data set. Is it data set or data sets? Data sets. Data sets library. When I use load dataset, I get, I get a warning saying that, what did the warning say exactly? You know what? I'll pass this in. Explain this to me. Why must custom code be executed? I kind of have an idea of why that's required because there's probably a couple of steps that are near. It's not like ready. It's not the data might not necessarily be readily available. Maybe there's some processing that needs to be done. Or maybe the data gets downloaded in a certain way and then it gets it gets split up into like a more or processed into a more usable form. There might be any number of reasons, but I still kind of want an answer just to, get an answer. When you encounter a warning or error indicating that a repo contains custom code that must be executed to correctly load the dataset using the Hugging Face datasets library, here's what it typically means. Custom dataset scripts. Some datasets on the Hugging Face hub are not just simple collections of data files, but may require additional processing. Yeah, okay, there it is. Or specific loading mechanisms. These datasets often include custom scripts that need to be executed to prepare the data correctly. This is particularly common for datasets that are complex, large, or require specific pre-processing steps. A reason for custom code. Here are some reasons why custom code might be necessary. Data pre-processing. The data may need specific pre-processing steps such as data cleaning, feature extraction, or transformation, which are not handled by the standard load dataset function. Complex data formats. Some datasets may be stored in complex formats that require custom scripts to parse and load correctly. External dependencies. The dataset might be the dataset might depend on external libraries or resources that need to be downloaded or set up before the data can be loaded. Dynamic generation. In some cases, the dataset is generated dynamically based on certain parameters or conditions, requiring custom code to generate the data on the fly. Okay, how to handle custom code. To load such datasets, you typically need to follow these steps. Download and prepare the okay, all right. Alternatively, you might need to download and prepare the dataset manually and then load it using dataset.from pandas or dataset.from dictionary. Execute custom scripts. Sometimes you may need to, okay, all right. If a dataset is too large or complex, you might need to use streaming or other alternative loading methods to handle it efficiently. I need to explore this streaming thing more. Like, what does streaming mean here? Is it downloading it in like chunks? So, like, eventually you end up with the entire data set, or is it that you're constantly communicating with some outside source to read the data set? That seems very not so performance friendly, but I guess it would depend on the situation, right? It depends on what you're trying to do with the data set. Either way, okay. Do you wish to run custom code? Yes. Let's run the custom code. And there's an error. Okay. Oh God, this is. An error happened while trying to locate the file on the hub. We cannot find the requested files in the local cache. Please check your connection and try again. Did I spell something wrong? Didn't I just copy paste the entire thing? All right, let's try running it again. My God, dude, this is so fast. Holy shit. Some of the weights for so and so model were not initialized from the model checkpoint at so and are newly initialized. You should probably train this model on a downstream task to be able to use it for predictions and inference. I like that it gives you these bits of information. Okay. What is this? Oh, this is the data set. All right, so I should explore the dataset thing as well. So this is good. We got introduced to pipeline and dataset, and I think we're gonna get introduced to something else as well soon. What is where was I? I think I was here. Okay. The audio files are automatically loaded and resampled when calling the audio column. Extract the raw waveform. Oh, yeah, okay. So the dataset is downloaded, right? Once the dataset is downloaded, it's going to be using, uh, it's going to be cached, and we're going to be using the cached version. Right, so let's try exploring the dataset. Okay. Uh, you know what? Just to avoid this warning each time. Okay, so this is the dataset. Cool. What are what are the things that we can get from this? Okay, builder name, cache files. Um, okay, what does cast column do? Let's see, because we are calling cast column, right? Cast column to feature for decoding. The typecasting is applied to all the data sets of the dataset dictionary. Wait, cast column to feature for decoding. Feature type. All right, we'll look into this later. What else do we have? Oh, column names. Okay. Data. There it is. So let's get the type of this. This is a memory mapped table. Okay. All right. You know, let's create a new thing so I can use that as well. Okay, dataset dot columns. Column names. All right, so we have path, audio, transcription. Wait, where's the data being stored? I just thought about that. Where's the data being stored? Because I think data gets stored in input. Oh, no, it gets stored in output in this directory, right? Or is that only when you actually I don't remember. Where's the data being stored? I need to look into this later on to see where the data is being stored exactly in Kaggle notebooks. Okay, path, audio, transcription, English transcription, intent class, and language ID. All right, cool. Sorry, zoned out. Okay. Um, yeah, dataset cost column. Let's do that. Dataset equals dataset dot cost column. We are trying to cast audio to something. to actually wait. I wanna try reading the because okay, how do I get the types? How do I get the types of all the is D types a thing or is types a thing? Uh, data set size. No, data. Data dot columns, column names. No, that's drop. It says memory mapped table. Datasets.table.memory map table. All right, let's see columns. Is this just printing out all the data? Okay. All right. What was I gonna do? Yeah, I was gonna try and find the type of all of the data. Like, would I be able to do something like this, for example? Let's see if that works. Okay, so we have a table or a memory mapped table, I think it's called. I don't remember. Hold on. Yeah, we have a memory map table, and each column of that memory map table is is a chunked array. Can I get a length of this? 563. Which means if I did data.shape, we would be seeing 563 rows. Yeah, okay. 563 rows and 6 columns per row. Okay, all right. Oh, you know what? It's a I forgot what that thing is called, but it's a chunked array. Oh yeah, that's what it's called. Chunked array. Can I get the type of this? Um, no. This is what I want the type of. Okay. So it's a struct scalar. Okay, this is crazy. All right, what other column names do we have? Okay, print dataset dot column names. Uh, so let's say path. Oh, I'm trying to get the type. Okay. Oh, well, I guess that answers my question as well as to where the data is being stored. It's being stored in the cache. And in this case, I don't even need to worry about having to download the data because my God, dude. As I'm talking, I'm feeling my nose get stuffy. Okay, it's fine. Oh, for the first time, I'm actually noticing the RAM usage go up, and I'm super happy that I don't need to worry about the RAM in this case. Okay. Uh, what else was I gonna do? Okay, so we have path. We have let's print out the column names each time. Oh God, don't print the entire path thing. Just one is enough. Let's say transcription. I would like to set up a joint account with my partner. Okay. Then there's the English transcription. Um, oh, there's an English transcription and just transcription, meaning there could be other. Well, actually, there are other classes as well, right? There intent class 11, lang ID. So these are just going to be like indices of something, or well, IDs. I need to get a. How do I get the intent class? Can I just can I just access intent class and I'll get a list of the intent classes? Or can I access it as like a dictionary and it'll give me. No, that doesn't. No. Wait, will it? Let's try. Let's try. Oh, that worked. Okay. Wait, no, that didn't work. It accessed the entire thing as yeah, I basically did this. Yeah, there it is. Though it's kind of interesting how when I'm reading it from data, it comes out nice and structured, but when I'm reading it through this and well, okay, yeah, so they've probably set up different mechanisms for, indexing. So this gets read out in this way. Um, what did it look like here? Oh, so here I think we are getting a one by one thing. Like if I read the shape of this, it should say one by one. It has no attribute shape. What about size? No, that's okay. Either way, my point was looking at this, thinking about it in terms of NumPy arrays. It looks like it's one row and one column. Okay, so right, let's get back to this. Uh, okay. Um, right. Let's just copy this whole thing. Okay, so we are casting it to audio, and we are using the sample rate feature extractor dot sampling rate. Okay. Speech recognizer. Where's that? Here. Okay. Yeah. Let's print this out as well. Let's print out the sampling rate. So what is it? Speech recognizer dot feature extractor. Oh, I guess that's more like a generalized. Is it? Is it? No, is it a generalized thing? Because okay, speech recognizer is a pipeline, meaning pipeline is what has the feature extractor, right? It's not like specifically a speech recognition related thing. Okay, and then sampling rate. So this this attribute is only going to exist, I'm assuming, if we have automatic speech recognition as a task or anything audio related. So if we have an audio related task, all right, let's comment this out. And okay, so the sample rate is 16,000, which is interesting. I didn't think I just assumed it would be the usual 44,100, but I guess it makes sense, right? 16,000 samples, because that would make the that would make the data much smaller as well, because it's lesser number of samples per second. Okay, dude, you know what? I'm getting kind of tired. Okay, I've been like zoning out and stuff for a bit. Um, yeah, I think I'm gonna end here. I also won't raid anyone. Um, though I'm happy that we started with Hugging Face Transformers, and I'm definitely gonna move forward with this. I don't know what the next stream is gonna be, because I'm kind of excited about Transformers right now, and I kind of want to keep going with that, and eventually get to the point where I'm able to use Transformers to do stuff. And then at that point, I can, go back to doing stuff with scikit-learn and doing stuff with PyTorch, which we definitely need to get back to doing stuff with PyTorch, because we kind of paused at after training our first neural network. But yeah, anyways, I'm gonna end the stream now. I hope you guys have a nice day. Also, Sama, thanks for hanging out. Thanks for stopping by. Anyone else who might have been lurking in the chat, thanks for hanging out.